All right, welcome back. We are going to move on to the counting principle, the unit for combinatorics. And what this unit is about is basically figuring out how many ways you can arrange things, okay? The most basic stuff that we need to go over is the fundamental counting principle. Okay, so before we do that, I just want to uh, show you what it means, okay? What I mean by how many ways you can arrange things. So here's the warm-up question. It says, list all the ways to rearrange the letters A, B, and C. Okay, so if we want to arrange these three letters, obviously we can write it as A, B, C. Okay, now what other ways can there be? Well, let's say if I fix the first letter to be A, then I can write it as ACB. And that's all the option that I have for the arrangement where A is the first letter. I can start with the B as the first letter, then I can have BAC, BCA. Same thing, I can start with C, then I could have CAB or CBA. And that is all. Okay, that is the total number of ways I can rearrange these three letters. So in this case, there are 6 different ways. Okay, there are 6 different ways. Now, this is not too bad because we only have 3 letters. What if we have a lot of letters, right? Do we really want to list all of them out? There must be a shorter way to come up with this number, right? And this is when we use the fundamental counting principle. Okay, so what this is that if we have a number of choices for object A and B number of choices for object B, then we have a total of A, so the number times B ways to arrange them. So this is to arrange. Okay, so this is the fundamental counting principle. Now this is true if we have more than just 2 objects, right? If we have 3, then it's A times B times C. If it's 5 different objects that you need to have choices for, then it's going to be A times B times C times D times E and so on. For this our warm-up question, we have 3 objects, right? Namely, we have 3 letters, right? I sometimes call these the placeholders. Okay, so we have 3 placeholders. For the first letter, well, we have 3 choices. Okay, namely A, B, and C. For the second letter, we now only have 2 because we already picked 1 for the first letter, and therefore I only have 2 letters left for me to choose from. And then lastly, well, I have no choice other than the one that's left. And you can see 3 times 2 times 1 is equal to 6. That's exactly 1, 2, 3, 4, 5, 6 different ways to arrange these 3 letters. Okay. So this is what we call the fundamental counting principle. Okay, so let's look at the first example here. It says a fan has 3 settings: off, low, and high. How many ways are there to set these 3 fans? So then again, we have 3 objects, namely 3 fans. Okay, now for each fan, we have 3 choices, right? It's either off, low, or high. So we have 3 choices for the first fan, 3 choices for the second fan, and 3 choices for the third fan. So in total, there are actually 27 ways to have different settings. Okay, there are 27 settings in total for these 3 fans. Okay, the second part says, what is the probability that one fan is on low, one fan is on high, and one is off? Okay, so now we want one of them to be low, one of them to be high, and one of them to be off. So really, what this question is then, well, first of all, probability simply means it's gonna be the possible outcomes divided by the total number of outcomes, right? So, or I should say, the favorable outcome, which is in this case 1 low, 1 high, and 1 off, divided by the total number of outcomes. So what are how many favorable outcomes are there? Well, this is basically telling us how to arrange these 3 letters: low, high, and off. Okay, I have 3 letters, and how many ways can I rearrange these 3 letters, right? Because I mean, each setting could be for each fan, right? So it doesn't really matter which one is which, as long as each fan has one of these settings, okay? So then, well, this then basically is just like our ABC question. How many ways can I arrange these 3 letters? That's going to be 3 times 2 times 1, which is going to be 6. So this is the total number of favorable outcomes. Now the probability then is just going to be low, high, and off is then going to be 6 out of the total number of outcomes, which is 27. Okay, so again, 6 is how many ways we can arrange these 3 letters, simply meaning that one is on high, one is on low, one is off, and out of the 27 total possibilities. So 6 out of 27, which we can reduce. I'm not too worried. Okay, so that's just what it is. Okay, 6 out of 27. Okay, so here's the practice question. Give it a try and see what you can come up with. Okay, so it says a toy manufacturer makes a wooden toy in 3 parts. Part 1, there are 3 different colors. Part 2, there are 2 possible colors. And part 3, there are 4 different possible colors. How many different colored toy can be produced? So then again, we have 3 parts. Each part, we have different number of choices, right? We have 3 different colors to choose from for the first part. For the part 2, we have 2 different choices, and the last part, we have 4 choices. So if you multiply them together, you should get 24. So there could be 24 different combinations of colors of this toy. Okay, so that's it. Okay, so not too bad, hopefully. The calculations for this unit is quite simple. You just multiply. Okay, and sometimes the numbers gets quite big, then we just need to use a calculator. But really, it's about thinking. Really, this is logic. This unit is calculation is easy, but to come up with what you need to do is hard. Okay, you'll see what I mean in a second. Okay, it does get quite a bit more challenging. Okay, so here's example number 2. For an online banking account, the minimum security standards requires a password to have 2 letters followed by 5 digits. How many different passwords are possible? So there are 2 scenarios here. Part A, all letters, it should say and, all letters and digits may be used more than once. Okay, so first of all, we're going to have 2 placeholders for the letters and then 5 numbers. 1, 2, 3, 4, 5. Okay, now 2 letters. There are 26 letters in alphabets, right? A to Z, 26 letters. It says all letters and digits may be used more than once. So then I can repeat them. So I still have 26 choices for the second letter. Now for the last 5 digits, well, I have 0 to 9, so there are 10 digits. Okay, so be careful, not 9, 10 digits, 0 to 9. And again, I can repeat them. So I have 10 digits for each of the following placeholders. So then again, you can see it's not difficult as long as you just need to, and now you just need to multiply. So if you put this into a calculator, you should get 7,760,000 possibilities. Okay, 700. Oh, no. Oh my goodness, I'm missing a 0. So it's 67,600,000. Okay, so there's a lot of choices possible. Okay, part B, none of the letters or digits may be repeated. So if you think about this, if you cannot repeat them, right, that means the number of possibilities should decrease. Okay, so you should keep that in mind, right? Your final answer should be less than what you had in part A because you cannot repeat them. Therefore, you should have less possibilities. Okay, so same thing. First two placeholders are letters, so I have 26. Since I cannot use them once again, therefore I only have 25 letters left. Okay, I have 10 digits to start with, and I'm going to decrease by 1 each time as I used 1 already, right? And again, all you need to do is put this into calculator, and I believe you should get 19,656,000 possibilities. So about a third. Okay, around actually less than a third. What is this? I don't know, 40%ish, something like that. Okay, I'm not sure. Put it into calculator, you can figure out. But definitely less. Okay, definitely less. Okay, practice 2. So I want you to try these. Yeah, this is where things are starting to get interesting. Okay, there's more restrictions, so you just need to think about a little bit more. Part A should be easy. See how you do. Okay, so it says determine the number of distinguishable, so again, different, 4-letter arrangements, 4-letter, okay, only 4, that can be formed from the word English. So from the word English, there are 7 letters, okay? Now we are only forming a 4-letter arrangement. So we only pick 4 letters out of those 7. So then that means this case we have 4 placeholders, right? Because we're only forming a 4-letter word, okay? So English, it says letters cannot be repeated. Well, I have 7 letters to choose from to begin with. And since I cannot repeat them, so I'm going to decrease by 1 each time. So it's going to be 7 times 6 times 5 times 4, which gives you 840. Okay. Part B says the first letter must be E. Okay, so same thing. I am going to start with 4 placeholders. Now, the first letter must be E. Therefore, I only have 1 choice, right? It has to be E. I got nothing else, right? Nothing else to choose from. Now for the second letter, it's just going to be, well, because E is taken, so that means I still have 6 letters left for me to choose from, and then 5, and then 4. So if you multiply them together, you should get 120. Okay, hopefully that's what you got. Part C, it says the first and the last letters must be vowels. So again, 4 placeholders. The first and the last must be vowels. From the word English, I have 2 vowels, simply E and I. Okay, so for the first letters, for the first letter, I have 2 choices. Could be I or E. For the last letter, I only have 1 choice left, right? Because if I used up E, then the last one has to be I, or vice versa, right? If the first one is I, then the last one must be E. Okay, for the middle 2 letters, well, I have 5 non-vowel letters. So I have 5 to choose from, and then 4. So then you should have 40 different arrangements. Okay, lastly, letter G must be used. Now, it only says G has to be used. It does not say where it could be. Okay, so really there are, okay, I'll show you. Okay, so let's say the first one is a G. So that means I have 1 choice, right, for the first letter. And then we'll have 6, 5, and 4. But again, the first one, we are assuming first one is G. But it could be the second one. It could be here. Or it could be the third one. Or it could be the fourth one. And you can see it's going to be 6 times 5 times 4 for the rest, for the other 3 options as well, right? It's going to be 6, 5, 4, 6, 5, 4, 6, 5, 4. So really, it's just the first choice or the first option, right? First possibility, and then times 4, because there are 4. Because G could be placed at 4 different places. So, or I mean, you could just do each one of those individually and add them together. Right? It's the same thing as if you just do the first one and times 4, because we have 4 possibilities for G. Right? G could be first, second, third, or fourth. And in this case, you end up with 480. Okay, so that's how many ways you can arrange 4 letters out of the English, the 7 letters from English. Okay. All right, hopefully you got no problem with those. Again, it could be tricky, I don't know. I mean, at first it's going to be hard, okay, trust me. But once you get used to it, it's not as bad as you think, okay? But you just need to really think about it. You need some practice, okay? Okay. All right, practice number 3, consider the digits 2, 3, 5, 6, 7, and 9. Okay, I'll let you try first, and then I'll show you the answer in a bit. Okay, part A says if the repetitions are not permitted, so we cannot repeat the digits. How many 3-digit numbers can be formed? So again, 3 digits, so 3 placeholders. Okay, you cannot repeat them. Okay, so I have 1, 2, 3, 4, 5, 6 numbers. 1, 2, 3, 4, 5, 6 numbers, right? So we cannot repeat them. So 6 times 5 times 4, 120. Okay, not too bad. Part B says how many of these are less than 400? Well, if you want this 3-digit number to be less than 400, that means the first digit has to be either 2 or 3, right? So really, I have 2 choices for the first digit, the 100 digit. Now, for the other 2, well, since I picked 1 already, so I still have 5 left, and for the last digit, then I have 4 left. So if you multiply them, you should get 40. You have 40 for the numbers, 40 three-digit numbers that's going to be less than 400. Okay, so that is all for this lesson. Yeah, try some of these questions. Hopefully, you'll get them quite easily. Okay, let me know if you have any questions. Good luck.